1, 2, 3, 4. We are live. And as I just tweeted, I'll bring the information that I put there here, which is for this last session. We will try to cover changing some flags for, excuse me, yeah, here, for building our first targets or target library with, how can I say this? With more robust flags, so I can investigate the code that is being triggered by the crash better. And I was just talking to a friend before this last session, and she told me that it would probably be better if in the beginning of each session I tried to give a short introduction of what I'm working on. And although I have been trying to do that, she is right that I'm still handling lots of concepts that are not easy many times, especially for a newcomer. So let's see if I manage to. Okay, I see that if I am to do that and the person is a total newcomer, then it's probably a lot, but let's try. Yeah, because no one knows who I am, right? Okay, so if you are new here, I'm doing the total YouTube / streamer thing now. If you are new here, I am Juliana Fajardini Reichel. I am an Outreach alum working as a full-time developer at OISF, contributing to the Suricata security network monitoring engine. And today let me also add that this is an open source tool. That is why I am able to even do such streams so freely, because all of the work I'm doing here is, the ticket is on our public project tracker. The pull requests are on, as the name suggests, on GitHub. So mainly I'm working with public tasks, so I can share what I do, and it's more a matter of feeling comfortable doing so. And that is something that I'm still learning to do, but I really think it's beneficial, so that's why I'm here. The other reason, two more actually, is one is because I'm trying to focus, as the title suggests, and talking to my screen / camera helps. And also because not long ago, while I struggled with coding, the result of my struggles would be I believing that I was not meant to do that I was not good enough to be a coder. And back then, when I would feel like that, I felt that that was true, that my feelings really meant that, and I end up giving up. So I dropped coding for a few years, and then, well, life came around, and I realized that working with as a programmer was probably my best shot in a long while for my life. So I decided that I would try that again, and I put a lot of effort. I applied for jobs, and it was not easy, but I decided that I would not close the doors. And I've learned a lot during this period. And one of the things that I learned was and is that many folks struggle, probably all of folks out there who are developers struggle at some point. So I decided that I would be more vocal and open about it. And especially as a woman from third world, I am from Brazil, all those things stack up and make us many times feel less confident about what we do, less confident about ourselves. And yeah, that's another reason why I'm doing this. I want to share what is my process, just so other folks who may relate with me, see what I'm doing, and realize that if you are struggling, that's just what a process is. It doesn't mean that you are not meant to be a coder. It doesn't mean that you are not good enough. It doesn't mean that you can't do it. Now, without much more words, let me just explain the technical side of, as much as I can, of what I'm trying to do. And that is, I have a task to make a certain aspect of Suricata configurable. It used to be a static value. That meant that it did not change, so it was defined, I don't know the better words for that, but I'll sort of say that it was defined at compile time. We are talking about C here, the language, and now we want it to be configurable, so it cannot be a static array. And when I changed that, making it a dynamic array, other things had to be changed because we found bugs. So I moved on to try to work on those changes. Actually, my mentor and the tech lead of Suricata, Victor, worked on it. Then another colleague, Philippe Antoine, found places where we had to improve what had been done. So I picked that up, and while I was trying to improve it, we found other bugs, and I tried to improve that. And now our continuous integration tool for fuzzing, not the whole thing, but the part that fuzzes our project to try to find unusual bugs, found a bug, and that's where I am. I'm trying to debug the issue that was found by our fuzzing tool, so I can fix it and hopefully finish this task. Just today, Philip made sure that we would have the CI failures checked, and that's what I've been doing at the moment. And for those who are not aware of fuzzing, it's, in short, fuzzing is a technique to test, and I think that is a technique to extreme test your tool by using random input. So you can test corner cases And so things that would not normally happen, you use fuzz input to go there and try to make it safer. So that was me trying to explain many concepts and things in a short-ish time. 10 minutes is definitely not short. And yeah, let's do this. And currently, the previous sessions have covered how to reach, that's not what we want, have covered, where is it? Is this the one? I think so. The previous sessions have covered how to reach a point where you have I'll talk about our case. So where you have Suricata running inside a Docker container with the fuzz targets, which are the tools, the library to test, as I just explained, your patches, your changes to test that, and I have managed to run it with the artifact that was generated by our fuzzing tool in the continuous integration checks that we have for our pull requests. It generates a binary file that you can feed into or to the fuzz target and reproduce the bug that was found. And in the previous sessions we did that. We were also able to run it with GDB in the hopes that we would be able to explore variables and the part of the source code that is generating the bug. But I think the compilation, the fuzz targets were optimized, so we don't have a lot of symbols available. I don't know what's the best way to describe this, but the fact is that I can't access much. And so what we will do in this session is try to change that. I'm not sure where will that happen, because this change will be done to the fuzzers, not to Suricata itself, but to the fuzzers. And I don't know where does that happen. So let's find out. So one thing to keep in mind, and I'm talking to myself right now, but well, is that I have run, I ran Docker through a helper script that OSS Fuzz provides. And this was the command that was used. The base runner debug. Remove privilege, IE, okay, this is, I don't know, type of architecture. Where is the code that we are working with? And I want to know, I guess we can investigate the flags that we have by its env grab flags, but will this be enough? Will I be able to? No flags? What did I do wrong? Let's see my annotations, my notes. it's not here. Let's go to where is it? Oh, yeah, it would never work. OSF Vim not here. Nope. Yeah, where is my mouse? I'm trying to find my notes on how to handle this, because CI fuzz, our very that sounds not as good. I need better words, but Philip had a session with Shivani and I where he explained a bit how we should go around running the fuzzers locally, and he did mention how to check the flags, but that is not enough. Maybe because all of that was done from outside, so now we don't have them. If I try to source Suricata, what do we have? Where am I? Source. Oh, it's everything is in out. Low. That is different. Oh. So when we have this, we do not get the whole Suricata code, just the fuzzers, apparently. Okay, that is new to me. I had no idea. This is the one that I'm running. And I don't know. Suricata has an option where we can know what were the building flags used. So if I do this, and it has been compiled, which I'm not sure if it was the case. Yeah, it was not. But if it were, I could know what configuration was used. So here, for instance, I would know flags that were passed before compiling. But we don't have it here. Oh, boy! Someone just startled me because I was very concentrated and they greeted me. In any case, you need, as usual, clang, and you have to instrument it with the code covered C flags we described in the fuzzer building section. Then start the fuzzer. I really wish this part was better explained, like detailing more. This, how can I find this? If I go here, there are so many mosquitoes today. Git grab fuzz, many things. If build fuzz targets, lib fuzzing engine. We are finding things that can be interesting. G. I think that when we call the helper script to build the fuzz targets, it will use this. So I'm thinking I will change this locally. Well, not this one, because this is for our workflows. But in our config file, we will have that somewhere. And I want to change that. What do they have? O1. I want to use O0. This is here, all right. But this is for the workflows. I want to know, what do we have when fuzzing? Well, when going with OSS fuzz. Fuzz readme, all right. Where do we find those info? Okay, not there. OSS fuzz. What do we have? Project Suricata. Project YAML. What do we have in the YAML file? Sanitizers. Main repo. Antoine. Cute, 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 cute. The home page has changed. Shall I submit a patch changing just the home page? Okay, so I have 3 files. So it's not there. No, let's. I think whatever related to fuzz comes from Philips repository. Fuzz bcap, but that is just for the corpus, right? Here we list things. OSS configure. This is just here we will be doing things already, and when we go there and we check that, let's see, source, tests, fuzz, OSS. Yeah, I need more flags here, way more. Where could they be? I'm assuming they are somewhere. Here we are building dictionaries. Okay. The corpus, the fuzz rules. Philip concatenates all Suricata rules into a single file. Corpus with a single file is alright. That's it. It has to do with enabling. I'll go with that. The first targets. But somewhere we need more than that. More, much more. And it's not in the Docker file. It's not. We do not have much info here, so it has to be, I guess, in the helper file. Or not. Export. Nope. There's more that I have to understand. Fuzzers. Build fuzzers. Build fuzzers. When we go with build fuzzers, I've checked this so many times and it doesn't talk to me yet. Check fuzzer exists. No. Build fuzzers. Project clean engine sanitizer, and to add source path, mount path. I don't know. What can I find if I look for Philip's paper on this? Where are the args coming from? OSS fuzz. Find flags. That sounds horrible. Mosquitoes are killing me. No. Maybe here. Flag. Why do you use Docker? No, but that's the only one. Creating the file structure, homepage, language, builds per day, Docker file, temporary disabling code, fuzzer execution environment. This looks promising. For more on the environment that your fuzz targets run in and the assumptions you can make, see the fuzzer environment page. Testing locally, that is where things did not work for me. You can build your Docker image and fuzz targets locally so you can test them before you push them to the OSS fuzz repository. Run the same helper script you used to create your directory structure, this time using it to build your Docker image and fuzz targets. The build binaries appear in the path to the out project name directory on your machine and out in the container. You must run your fuzz target binaries inside the base runner Docker container to make sure that they work properly. Find failures to fix by running the check build command. Do I have to do that? If you want to test changes against a particular fuzz target, run the following command. Run fuzzer, cool. Corpus dir project name fuzz target. Oh, this is interesting to know. I'll probably have to do that once I have any patches. We recommend taking a look at your code coverage as a test to ensure that your fuzz targets get to the code you expect. This would use the corpus generated from the previous run fuzzer step in your local corpus directory. This is a whole new world. You may need to run Python infra helper pull images to use the latest coverage tools. Please refer to code coverage for detailed information on code coverage generation. Note, currently we only support address sanitizer and undefined behavior sanitizer. I should learn how to use that one. Configurations by default. Memory sanitizer is recommended but needs to be enabled manually. Do I need that? Since you must build all runtime dependencies with memory sanitizer, make sure to test each of the supported build configurations with the above commands: build fuzzers, run fuzzer, coverage. If everything works locally, it should also work on our automated builders and cluster fuzz. If you check in your files and experience failures, review your dependencies. Debugging problems. If you run into problems, our debugging page lists ways to debug your build scripts and fuzz targets. Fuzzer environment on ClusterFuzz. Your fuzz targets will be run on a Google Compute Engine VM. Fuzzer environment on ClusterFuzz, runtime dependencies, argv0, current working directory, file system hardware. Runtime dependencies. You should not make any assumptions on the availability of dependent packages in the execution environment. Packages that are installed via Dockerfile or built as part of build.sh are not available on the bot runtime environment where the fuzz targets run. If you need these dependencies in the runtime environment, you can either install the packages via Dockerfile and then link statically against them, or build the dependencies statically in build.sh. All build artifacts needed during fuzz target execution should be inside the out directory. Only those artifacts are archived and used on the bots. Everything else is ignored. Artifacts in work, source, etc., and hence is not available in the execution environment. So that's why everything is copied there. All right. We strongly recommend static linking because it just works. However, dynamic linking can work if shared objects are included in the out directory and are loaded relative to origin. The path of the binary, see the discussion of origin here. Okay, origin is the path to the binary. A fuzzer can be instructed to load libraries relative to origin. You must not modify argv0. It is required for certain things to work correctly. You should not make any assumptions about the current working directory of your fuzz target. If you need to load data files, please use argv0 to get the directory where your fuzz target executable is located. Do we have anything about flags? Hardware. Your project should not be compiled with March native, march, not March, or mtune native flags, as the build infrastructure and fuzzing machines may have different CPUs as well as other hardware differences. You may, however, use mtune generic. All right, this is not the flag I'm looking for. I don't know enough. Debug. Oh, how do I have access to that? Should I look? Should I Google it? I don't know. Let's go to the same folder, shall we? All those are things that are outside. Okay. No. Clang. There are just too many things that I do not know. Philippe Antoine continuously fuzzing suricata. Keeping on fuzzing and fixing suricata. 1 year of fuzzing and fixing suricata. That's the webinar I want. I want papers. Yeah, that's the. This is so cute. I think I saw when we talked about this one. I want. Let's see. I'm hoping. No, that's not what I wanted. Let's just go to Latina Cyber. What? FR. What do we have here? Services for cybersecurity. About. Hello, Philip. Cool, cool, cool. I need. Where do I find your papers? Who says? Oh, okay. Service en cybersécurité. Conseil. À propos. Non, 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 non. Let's try. Philippe Antoine. Article. Suricata. I don't know how to. Maybe here, because he's famous, so I can't find things. Another Philippe Antoine. I'll have to check this one just because it's too much of a coincidence. I think that's not my Philippe Antoine. Mine. So, how did we get to this? Where is Suricata here? It's where? Yeah, I don't know how you do this. It's just nothing. Useless. Let me not look in English paper. I saw one of his today. Buster Fuzzlight now supports GitLab, coaching students from Telecom Nancy to use CodeQL to find bugs in Suricata and more. This is cool. Cool. That is old. If I like it, it will be weird. Cool. Where can I find papers? Give me papers. Les 5 derniers articles. Oh, this sounds interesting. Yeah, those were the ones at Suricon, and I want to student work recognized by the open source community and the Open Information Security Foundation. We are very proud to support an open source community project and to meet cybersecurity experts from around the world. Participating in this conference gave me papers. No papers. Okay. Sure. Philip, Antoine. Give me papers, give me. I gave up. What is this? On the occasion, oh, it's gone, of its open days, which will take place on Saturday, March 5, Telecom Nancy invites you to participate in its Cyber Escape game, a fun workshop to raise awareness of security breaches in computer systems designed by students and teachers from the school. Ooh. Oh, I wish I had seen it. I will check what I have locally. I'm ignoring the fact that I am frustrated. I'm not thinking about it. I'm not. I don't know. All of a sudden it looks like I never had anything. Things are happening to my phone. Okay, was not able to find a paper. I thought I would. Mirror track. Interesting. What? Can I find something here? I wonder if anyone will be able to see anything here. Maybe I could check those and that would help me. Another change was to introduce a structure-aware fuzz target. PCAP is the de facto standard for network traffic representation. Since PCAP is a complex format in itself and we wanted to fuzz Suricata instead of libpcap, we created a fuzzing-friendly libpcap-like library. This is the fuzz pcap that we see. This allowed us to compute a list of packages for one single TCP stream with the sequences and ACK numbers. With this in place, we do no longer fuzz the TCP reassembly engine, but rather the deep core of Suricata. While the new structure-aware target found 9 new bugs, the old target still found 1 bug since the introduction of the structure-aware target, which is the pre-def aware thing. This is a lot. I got nowhere. That is how far I got. No bleep where. What was the last? It was not very smart. What else could I check? Flags. Okay. Base builder. That has potential, I guess. Why didn't I check this before? Advanced topics, ideal integration. Do I have this when I... Where is the documentation? OSS Fuzz, advanced topics. Ideal integration. OSS projects have different build and test systems. We can't expect them all to implement and maintain fuzz targets or integrate them with OSS Fuzz in the same way. However, we do have recommendations. This page documents several features, starting from the easiest that will make automated fuzzing simple and efficient, and will help you catch regressions early in the development cycle. This simple example covers most of the items. So where's the example? Flag. Build support. Many different build systems exist in the open source world. The less OSS Fuzz knows about them, the better it can scale. An ideal build integration for OSS Fuzz looks like this. For every fuzz target foo in the project, there is a build rule that builds foo fuzzer, a binary that contains the fuzzing entry point, contains LLVM fuzzer test1 input, I saw that, and all the code it depends on. Uses the main function from libfuzzing engine, mvar provided by OSS Fuzz environment. Since the build system supports changing the compiler and passing extra compiler flags, the build command for foo fuzzer looks similar to this. Assume the following mvars are set. This minimizes OSS Fuzz specific configuration, making your fuzzing more robust. There is no point in hard coding the exact compiler flags in the build system because they A, may change, and B, depend on the fuzzing engine and the sanitizer being used. What if these are the only debugging? What? Where is it? I do not understand this. I don't know. I really don't. Just wherever. Okay, I feel this was useless. Again. It's almost an hour. I didn't get anywhere. I need I need more, and I don't know how. But it's been 1 hour. It's time to take a break or call it a day. It's late. I don't have much to add. I might explore this, like the base images, and see if I manage to find something that would help me. Well, this, what does the README say? Script to automate common Docker operations. Builds a Docker image for a given project, builds fuzz targets for a given project, runs a fuzz target in a Docker container, runs fuzz targets in a Docker container, and generates a code coverage report. C, runs a test case to reproduce a crash, which is what I would like to do. But I don't want to just reproduce, I want to debug it somehow. Base runner debug. Docker file. Base runner. All right. Many things. Coverage helper. Run further targets list. README. I think I just checked that one. Um, export. Nope. Flag. Oh no. G. No. No. Base images. Base image again. Docker file. Oh. Base builder. Bazel build fuzz tests. Compile libfuzzer sounds good. Docker file. And set C flags and C++ flags. Okay. If those are unset, do you set them again? I am so lost. Oh. Oh, compile. You're a binary. I just don't. Every project image supports multiple commands that can be invoked through Docker after the image is built. Supported commands. Compile, drop. Build all fuzz targets. Okay, so compile is what I want, which is what Philip has suggested as well. You must use special compiler flags to build your project and fuzz targets. These flags are provided in following environment variables. Most well-crafted build scripts will automatically use these variables. If not, pass them manually to the build tool. Oops. Just wherever. Check out build install. Nope. Docker file. I found something. I found something. Just that. I'm going places. I'm sure I should not go places. I don't even recall. There's it. Fuzz CFlags. Do I have that somewhere? If not, I'll be changing this Docker file. I will. Fuse fuzz CFlags. Nope. Well. Yeah, let's try again. Okay, very few use that. I'll go with infra base images base clang Docker file. This sounds not right, but it's the best I have. I did it. After changing that, I probably would have to quit this. So what was the last command? That is for running the debug. That's for copying. That is for building the fuzzers. And I think that building the fuzzers, I won't be able to see it now, but I will. It's been a while. I will run this and see if this generates the output that I am expecting, and if it does, I suppose I'll let folks know and say how happy I got. But I think that's it. Let's hope I don't break anything. But yeah, can I check this? Where they show the flags. This is what I have to find, compiling libfuzzer. Maybe I should look for this, and this would help me. Otherwise it will just be the clang thing, but it's some other thing that I could check. I'll just write it down. Search for compiling libfuzzer. I hope I didn't break it. Okay, so what is this last session's outcome? I would say that things can get way more frustrating than expected fairly easily, and sometimes it's just the way things are. Sometimes we have to just assume, or not assume, but accept we will need help. I think everyone watching this clearly knows it's time for me to do that. I probably would have at this point, but Philip, the colleague that I have mentioned, is ahead of me in time, and when I got to this point, I think he had already finished his working week, and Victor has been fairly busy because he has a lot going on. He has a lot on his plate, and as we have a meeting, a call on Monday, I decided that I would just try a bit longer. But yeah, don't get stuck for this long if you can avoid it. I will, as I said, leave this rolling. I can see that some of the things do not have the flags that I want. So on Monday, I will try to find the best place for putting this. Maybe if I search for the other flags, this will help. Possibly as well, when I search for compiling libfuzzer, it could do. I have to find out where exactly the fuzz targets are built, and that because I failed in doing that. But yeah, well, other things worked today. I would like to say I'm getting more resilient because I keep trying, and I don't know, I'm moving forward, right? Oh, there's something there. I hope it's just a gecko. I don't want roaches. I really don't. And yeah, it's been interesting doing shorter sessions. I'll try to always start with a short introduction about who am I, what's the project I work with, why am I doing such sessions, and what is the goal of the specific session we are working with. And then I'll also have the wrap up. I'll try to keep those concise, otherwise my 1 hour session will become much shorter because I talk too much. And that is it for today. As I said, I'll give some update about this offline, of course, but that's it. There's always some bot, I think, who keeps joining my lives, and it's good to have a viewer there that gives me this idea that there's a ghost watching me. Talker mode. That's it. Have a nice weekend, or whenever you are watching this, if anyone ever watches this. Thank you. Bye. That's it for today.